In this video, we're going to be doing a review about how exponents work, as well as looking at a variety of shortcuts that we can use in order to simplify more complicated expressions of exponents. So to begin, let's review what the components of an exponent are. So there are always two numbers that are represented in the exponent. For example, if we use the big number 5 here, the big number of the exponent is what we call the base. This is the number that we multiply by itself. And then the little number at the top, in the top right specifically, is the actual exponent that tells us the number of times that we multiply the base by itself. For example, 4 to the exponent 3 means that we are multiplying 4 by itself 3 times. Then, if we multiply 4 to the exponent 3 by 4 to the exponent 2, we're taking 4 multiplied by itself 3 times and multiplying it by 4 again, but multiplied by itself twice. Now we can see here that if we multiply 4 by itself this many times, we can simply write this as 4 to the exponent 5, which makes it a lot more straightforward to actually solve using your calculator. This simplification is what we call the multiplication rule. So whenever we multiply exponents, we can simply take the total of the two exponents as long as the base is the same and then add the exponents together. So 4 to the exponent 3 multiplied by 4 to the exponent 2, 3 plus 2 is 5. And we can see that this lines up perfectly with how we would write out the expanded form like this. Now, we have a similar rule that involves what happens when we divide two exponents by each other. So, if we take 6 to the exponent 5, this means that we are taking 6 and multiplying it 6 by itself 5 times. And we all know that the fraction line means division, and we're dividing this by 6 multiplied by itself 3 times, like so. Now, we can simplify this because if we remember that any time we take any number and divide by itself, we can write this as 1, meaning that we can cancel the two numbers that apply to both the top and the bottom of the fraction, because these two just become 1, and multiplying 1 by anything doesn't change what the other number is. So these two 6's we can cancel, these two 6's we can cancel, and these two 6's we can cancel like this, leaving us simply with 6 times 6, which we can write as 6 squared. Now, when we do exponent division, this is often why it's referred to as the subtraction rule. For example, using our exponent division that we did, 6 to the exponent 5 divided by 6 to the exponent 3, if we simply take 5 minus 3, we get 2, and therefore we can write the overall exponent as 6 to the exponent 2 simply by subtracting the two exponents that we are dividing. Now, for our third rule, what happens if we are taking the exponent of an exponent, so to speak? Well, the first thing that we can do is we can write what's in the brackets. So this would be 2 to the exponent 3. So 2 multiplied by itself 3 times. 2 times 2 times 2. Now, remember that an exponent just tells us we're multiplying the base by itself. So in this case, because 2 to the exponent 3 is written in the brackets here, and the exponent that we're raising it to is 2, that tells us that we're simply doing 2 to the exponent 3 multiplied by itself twice. Now, we know that 2 to the exponent 3 is 2 times 2 times 2, so if we multiply 2 to the exponent 3 by itself twice, we would have 2 times 2 times 2 times 2 times 2 times 2. Well, here we can simplify this to 2 to the exponent 6 because we are multiplying 2 by itself 6 times. Now, if we want to see the shortcut that we can use here, 2 to the exponent 3 raised to the exponent 2, we can see that in order to get the number 6, we take the inner exponent and the outer exponent and multiply them together. And this is the shortcut that we can use for exponents of exponents, by taking the exponent in the base, the inside of the brackets, and multiplying it by the exponent outside of the brackets, like so. And we can see that it works perfectly like this. Now, the next example is not really any variation to the rule. It's just looking at what happens if we have a fraction inside of the brackets. Well, here we treat the exponent no differently. So here, in this case, our base is not an integer or a natural number. In this case, our base is a fraction, 2 over 3, and our exponent 2 simply says that we're multiplying the fraction by itself twice. So 2 over 3 times 2 over 3. Now, in this case, we can rewrite the fraction as 2 times 2 in the numerator over 3 times 3 in the denominator, like this. In other words, we can rewrite this exponent as 2 to the power of 2 divided by 3 to the power of 2. In other words, we can simply say that when a fraction is the base and you're doing exponents of fraction, the exponent applies to both the numerator and the denominator. In other words, the 2 over 3 squared means that we can simply write this as 2 squared divided by 3 squared in order to make it easier to represent like this. In part 2 of this video, we're going to be looking at less well-known rules involving exponents, specifically what happens if the exponent is negative and what happens if an exponent is 0. So join us in part 2, where we will explore the less well-known rules of exponents.